Python error handling. Every program encounters errors. Files go missing, networks fail, users enter bad data. Good error handling is the difference between a program that crashes with a confusing traceback and one that tells the user what went wrong. In this video, we will cover try except, custom exceptions, and the best error handling patterns. Use try except to catch errors and handle them gracefully. The try block runs the code. If an error occurs, Python jumps to the matching except block. If no error occurs, the except block is skipped. Without error handling, dividing by 0 crashes the program. With it, we return none instead. Always catch specific exceptions. Never use a bare except without a type. It catches everything including keyboard interrupts and system exits. If you are not sure which exception to catch, let the error happen first. Read the traceback, then add a specific except clause for that type. The common built-in exceptions include value error for wrong values, type error for wrong types, key error for missing dictionary keys, index error for out-of-range indices, and file not found error. All of them inherit from exception. You should only catch exceptions that inherit from exception, never base exception directly. The full try statement has 4 parts. Try runs the code. Except handles the error. Else runs only if no exception occurred. Finally runs always, even after an exception or a return. The else block separates error handling from success logic. The finally block is for cleanup code that must always run. Without the else block, you might accidentally catch exceptions from your success code. With else, only the code in the try block is protected. Errors from the else block are not caught. This is a subtle but important distinction that prevents hidden bugs in your error handling logic. Create custom exceptions by inheriting from exception. Start with a base exception for your application. Then create specific exceptions that inherit from it. Custom exceptions carry extra information like resource type, field name, or error message. This gives callers flexibility to catch broad or specific errors. Here is a realistic example using custom exceptions. The getUser function raises not found error when a user does not exist. The validate email function raises validation error for invalid input. Callers can catch the specific error type and access extra information like the resource name or field. When you catch one exception and raise another, use raise from to preserve the original error. This creates a chain that helps with debugging. Without from, the traceback says another exception occurred, which is confusing. With from, it clearly shows the direct cause of the error. Exception groups let you collect multiple errors at once instead of stopping at the first one. This is common in form validation. Validate all fields and collect every error. Then raise an exception group with all errors. Users see all problems at once and can fix them in one go. For simple cases where you just want to ignore a specific exception, use contextlib.suppress. It is cleaner than a try except that does nothing. Use suppress only for simple cases where the except block would be empty or just set a default value. For complex handling, stick with try except. Python has 2 error handling philosophies. LBYL means look before you leap, checking for errors before they happen. EFP means easier to ask forgiveness than permission, trying first and handling errors after. Python strongly prefers EFP because it is often faster and avoids race conditions. The exception hierarchy starts with base exception at the top. System exit and keyboard interrupt inherit from base exception directly. Most exceptions inherit from exception. Never catch base exception because it includes keyboard interrupts. Catch exception as the broadest reasonable catch, but prefer specific types. Here is a comparison of error handling patterns. Try except handles expected errors. Try except else separates error handling from success logic. Try finally ensures cleanup. Custom exceptions add context. Raise from preserves the original error. Exception groups collect multiple errors. Common mistakes include catching too broadly with a bare except that hides real bugs. Silencing errors with pass means you never know something went wrong. At the very least, log the error. Using exceptions for normal control flow is also a bad practice. Exceptions should be for exceptional situations. Another mistake is catching exception when you only expect value error. This hides bugs like type errors and attribute errors. Always catch only what you expect. Let unexpected errors bubble up so you can find and fix them during development. Be precise with your error handling. Here is a comparison of the built-in exception types. Value error is for wrong values. Type error is for wrong types. Key error is for missing dictionary keys. Index error is for list indices out of range. File not found error is for missing files. Zero division error is for dividing by zero. In the next video, we will learn about file I/O, reading, writing, and working with JSON, CSV, and temporary files. Good error handling is essential for file operations because files can be missing, locked, or corrupted. The patterns we learned today will be used throughout the rest of the series. If you like this video, hit the like button and subscribe for more tutorials.